everyone! In this video, we will solve an example problem in Chapter 9, which is about the overview of heat transfer in conduction. The inner and outer glasses of a 2 meter by 2 meter double-pane window are at 18 degrees Celsius and 6 degrees Celsius respectively. If the 1 centimeter space between the two glasses is filled with still air, determine the rate of heat transfer through the window in kilowatts. So, in the problem, the inner and the outer glasses of a double pane window with a 1 centimeter air space are at specified temperature. The rate of heat transfer through the window is to be determined. So, before we will solve the problem, we must identify first our given. So, we have here 2 meter by 2 meter as the area of our glasses. And also, we have here the 1 centimeter as the length. And we have here 18 degrees Celsius as our initial temperature, 6 degrees Celsius as our final temperature. So, we will assume that the steady operating conditions exist since the surface temperatures of the glass remain constant at the specified values. Also, the heat transfer through the window is one-dimensional and the thermal properties of the air are constant. The air trap between the two glasses is still, and thus the heat transfer is by the conduction only. So, given by the equation of the heat transfer by conduction is equal to the thermal conductivity multiplied by the area multiplied by the change in temperature all over the length. Since our thermal conductivity is unknown, we can obtain this value from the table 2-3, which is the thermal conductivity material. So, we have here the air and having thermal conductivity of 0.026. So, let's go back into our equation. So, we have now the thermal conductivity multiplied by the area multiplied by the change in temperature at state 1 minus the state 2 temperature all over the length. So, let's plug in these values in this equation. So, we will have now 0.026 watts per meter degrees Celsius multiplied by 4 squared meter multiplied by 18 degrees Celsius minus 6 degrees Celsius all over 0.01 meter. So, plugging the values in the calculator, we will now have the rate of heat transfer through the window, which is equal to 125 watts. Since in the problem, we are asked to express the answer in kilowatts, since there are 1000 watts in 1 kilowatt, the 125 watts will be converted by multiplying 1 kilowatt over 1000 watts. So, we will now have the rate of heat transfer by conduction, which is equal to 0.125 kilowatt.